and this is my physics lab 2 on gravity and drag. So the intro of this project and the purpose is that we aim to demonstrate the practical application of physics principles by analyzing the motion of a falling object in the frame of the force of gravity and the drag force on that object while it is falling. We want to validate the fundamental physics concepts of the net force and the impact of opposing forces on the motion of an object. So the foundation is the non-zero net force, the force of gravity, and the drag force. So we're studying how when an object moves and there's different forces acting on it, how does the movement change? And so the initial equation we'll use is Fg equals negative mg times g hat. In this case, m would be the mass, g would be the acceleration of gravity, and j hat is the direction vector. The drag force would be b, so the constant b, constant of proportionality b multiplied by v squared, and then F net is just the sum of the forces. And so the diagram of forces here, it would be gravity is pointing downwards with the drag force of gravity pointing upwards. So in the gravity only model, it's only gravity. In the gravity and drag model, the drag force opposes the gravity and as it moves to the fluid object. And so here's a brief preview. It goes over the data and how the data might move as our bag falls to the ground. And so we're checking the y displacement as we drop it. So this indicates the mass and as it drops for the course of 0.535 seconds. Our falling object with VPython, and we're studying the motion of the object. So we've taken the mass to be 0.15 kilograms, with the initial velocity being 0, and another day being like a third of a second. And then so we're studying that over the course of 0.535 seconds, does it fall, and how it falls. And so if you run the program, we can see that the gravity is pointing downwards, with this graph showing a downwards curve and the velocity being constant. Drag force and gravity together, we have similar equations with F naught over t being, F naught over m being our acceleration determinant times delta t to find a new velocity, and position being updated as well. And the initial velocity is again 0 with the same third of a millisecond interval. And so if you run the program, we can see a much faster fall with the drag force pointing up, and then the curve is similar, yet the velocity seems to be curving down at a different rate. Spreadsheet. Here we have all of our data on an Excel spreadsheet, and we're looking as the object falls through the air and looking at the different models. There's 3 different models on here. There's one that with just gravity, there's the observed model, and then there's the gravity and drag predicted model. The orange line, which kind of diverges away from the rest, it's a gravity only model. And then we have the gravity and drag model, and then the observed model, which are pretty closely aligned. There is some gap between what was observed and the gravity and drag model, meaning that there are other factors that weren't accounted for, yet it appears to be that the 3 lines still have a similar trajectory. So from this we can conclude something like the gravity model needs to account for the net force of the object as it moves through the atmosphere. And whereas the observed and gravity drag account for those factors, which is why they're very similar. Results for this project. So the drag force and gravity model align the most with the observed model. So we can look at it and determine that the observed model does involve the drag force and gravity, whereas the gravity model moved a lot faster than the other models and diverged and moved away. And so the B, or the constant of proportionality for the drag force, was 0.099, which is a good indicator of the accuracy of our experiment, as the number was repeated by other experiments. So what does this mean with regards to terminal velocity? Well, the drag force and gravity model predict the terminal velocity. We have 2 graphs right here, the gravity only and the gravity and drag. We can see that with the gravity and drag model, the velocity is changing and approaching a certain velocity, whereas with the gravity only model, the velocity is moving at a certain constant speed. So the drag force and gravity model predict the terminal velocity better. And this means that when there's drag force and gravity, the object reaches a point where the net force becomes 0 and the velocity becomes constant because there's no acceleration. But what if it was thrown downward? Well, the terminal velocity itself, its value does not change. However, we can see that the model on the right has a initial velocity, and the model on the left has a zero initial velocity. We can see that with an initial velocity, it takes longer for it to approach the terminal velocity. However, the terminal velocity will end up being the same. And we can see that with the zero velocity, it approaches it faster. But yeah.